Alright, time for another math. Easy solution. Here to discuss the brief intro to trigonometry, and we'll get sine, cosine, and tan functions. Okay, let's get things started. Just draw just a random, just a triangle. So if we were to draw it like this, okay, let's move it this way. Okay, if we were to this is an angle. This is angle theta. It's a Greek letter. It's usually used for angles, and we'll call this side opposite. And this is we'll just call this OP, and this is adjacent, and this one we'll just call this A, and then this right here is hypotenuse. We'll just call this an H. Alright, so basically by definition, yes, if we look at these, by definition, yeah, these functions are definitions or just ratios. They're basically just defined ratios. And then yeah, so sine, written as, you could write as sin. Sine theta, just a function, equals just a ratio of opposite over hypotenuse. And cosine theta, just a ratio of adjacent over hypotenuse. So that's all it is, just a ratio. This is very simple. And then if we were to go tan theta, all this is just a ratio of the ratio. So sine theta over cosine theta, and then this one would equal to basically opposite over h over adjacent over h, and then the h is cancelled, so all you're left with is opposite over adjacent. So it's basically ratio of opposite over adjacent. So that's what tan is. Okay, now if we were to calculate these angles, let's say if we were to look at, let's just draw this. This is an x-axis. We'll draw a y-axis. Oh, whoops. Okay, so that's a y-axis. If we draw that, let's say if we have an angle here, this is less than 90 degrees. Yeah, so this is H, this is OP, and this is adjacent. So again, this is theta. So if we were to, yeah, you would just use these regular definitions if it's less than 90. This is, let's just go less than 90 degrees. We would just use these, or less than equal to 90 degrees, or pi over 2. We would just use this regularly. But if it was like greater than it, if we were to go something like this, let's go with this side right here. So then if we look at an angle like this is theta. So this is for, yeah, theta greater than 90 degrees. So what we actually are supposed to do is just look at the reference angle. So then instead of doing it this way, all it is, we will look at this angle. And over here, this is OP, this is H, this is A. So this is all we do. So this is, we'll call this R. So when it's greater than 90 degrees, we just look at the reference angle. Reference angle. Or this is this is reference angle, or just the angle to the x-axis that's closest to it. So we just look at it this way. So if it was something like, if we got an angle like this is x, this is y. So if we had an angle like this, so this is an angle theta. All we're going to do is use this reference angle. And then instead of using, yeah, so then we'll look at this. Yeah, so basically if this was, let's say 350, let's say this is R, 350, and then this one would just equal to 10 degrees. So this would be 10 or negative 10, depending on this way. If you rotate this way, it's gonna be negative. So it would be negative 10, or yeah, it would be negative 10. So basically, yeah, it would be negative, and then this way is positive. This way is positive. If you go counterclockwise, positive. Another way is negative. So clockwise, negative. So basically, sine, let's say 350 degrees equals sine of negative 10 degrees. So if we were to look at these negatives, I'll show you how to deal with those. So basically, let's look at the first quadrant. So then this is x, this is y. Yes, the first quadrant, this is, we'll call this 1, this is 2, this is 3, this is the fourth quadrant. So this angle, if we were to, this is just to see what's greater or negative or less than 0. So this is angle theta. Yeah, so basically, yeah, this is OP H over A. So as you can see here, this one, everything's positive. OP is positive. This one's greater than 0, greater than equal to 0. This is greater than or equal to 0. This one's this one's greater than equal to 0. So H is always greater than 0. This one's always greater than equal to 0 because it's just a distance between these. This one, you think about the y-axis. If it's going down, it's negative. This is x. If it goes here, it's negative. So basically, this one, all of them are going to be positive. So sine, cosine, tan, all of them are greater than or equal to 0. And then if you look at this side, OP, this one's actually, yeah, this is greater than or equal to 0 still, because it's still above the x-axis. It's just that this one is A, this one is less than 0. Yeah, so this one's negative. And then this one right here, yeah, it's less than or equal to 0. If you look at this angle. So less than or equal to 0. And then right here is H, just regular. So if you look at this side, A is negative. So then sine is basically, sine theta is equal to opposite over hypotenuse. So these are both positive. So this is greater than or equal to 0. Cosine, this one's equal to A over H. So this one, this is negative. This is negative. So it's less than or equal to 0. And tangent, yeah, tangent is basically opposite over adjacent. OP over A. And then this is negative, that's positive, so this is going to be less than or equal to 0. Similar to this one, if we were to draw something like this is an angle here. Yeah, just move this around. Yeah, just make that easier to see. So this angle, this one you'll have a negative OP. No, this is an or greater, and then this one is going to be H, and then this one's negative as well, negative A. We'll just write it like that. So basically, from quadrant 3, yeah, this one, yeah, quadrant 3 will have basically sine opposite over adjacent. Sine theta is opposite OP over A. This is negative. This is always positive. So then this one's gonna be less than 0. Cosine is same thing again. This is A over H. A is negative, so this is negative, less than 0. And then so cosine is in tan. If you look at tan theta, this one's actually opposite over H over A. This is negative. This is negative. So this becomes positive. So this is basically greater than equal to 0. You can see, so negative divided by negative is 0. Is positive. So now if you look at the fourth one, this is, so if we go to the fourth, basically just make it bigger like this. So this one you have a negative OP, H, and then this one's positive A. So similarly for the fourth, we'll just go like this. For the fourth, this is negative, so then sine is, again, this is less than 0. Cosine would be, would actually be greater than, because A is positive. And then tan is, again, it's going to be opposite over adjacent. Opposite is negative, adjacent is positive. This one is less than 0. And an easy way to remember the positive signs or whatnot is just basically doing this. This is an easy way to remember it. This is Y, this is X. We'll just call this A. A.S.T.C. And this is basically all of them are positive. This is all positive. Or all positive, or all call the students. Easy way to remember it, all students take calculus. So basically this is only cosine positive. It's greater than 0. This is tan. Is greater than equal to 0. This is all of them greater than equal to 0. And this is just sine. And this is actually useful. It's useful when you look at angles like this. Yeah, so that's an easy way to remember. All students take calculus. Well, they should. And then so if you have it this way, if you have an angle here, and then yeah, so basically this is, again, if you were to look at, this was 350, and then this reference angle is -10. So basically you look at the negative, yeah, so you look at the 10. So if you were to go sine 350 degrees, this just equals to sine -10 degrees. And then basically on this rule, this is y, this is x. So all students, A.S.T., this is A.S.C. all students take calculus rule. So basically only cosine's greater than 0. So sine's less than 0. So this one will just equal to sine 10 degrees. This is negative 10 degrees. And then you would just put in your calculator and get that. So basically, yeah, this is just an easy way to do it. And also, here's another way to get exact angles instead of using a calculator. So if you're, here's some trigonometry. Yeah, well, actually, I'll do that next time. I was gonna look at angles like pi over 4. This is pi over, pi over 2 and 0, and what else is it? Pi over 3, and yeah, and pi over 6. Yeah, this one is just 45 degrees. This is 90. 0 again. This is in radians. This is radians. I'll show another video how you can get exact numbers with this without having to put in a calculator. And this is just what is this one? 60 degrees. And this one is 30 degrees. So yeah, so I'll show you how with these kind of triangles, if you have a triangle like that, and this is 60 degrees, how you can get exact numbers for opposite, adjacent, or hypotenuse. And you could get the exact sign without a calculator. I'll show you in another video next time. But this is basically a quick intro to trigonometry with sine, cosine, and tangent, and a quick way to know what the negatives are, and how you have to use a reference angle, and then you'll see if it's negative or positive, basically by that rule. So yeah, so basically that's a quick intro. With angles, I'll show you later the graphs of them. It's actually used in many applications in real life. Well, thanks for tuning in, and stay tuned for another Math Easy solution.